Welcome to NIGHTOUT. In this lecture, we are going to start the second chapter, that is operations on a single random variable. So, in this chapter, the main topics are finding expectation or mean value of a random variable, then moments, that is moments about origin and moments about mean of a random variable, then moment generating function and a characteristic function. Next, we are going to discuss about Chebyshev's inequality. And finally, transformation of a random variable. So here transformation means converting one random variable into another random variable. So here I am going to introduce about these four topics now. So here we are having the random variable x. It can be either continuous random variable or discrete random variable. So the formulas are, if the random variable is continuous, then we are having this format. If the random variable is continuous, that means we are having infinite values. So we have to integrate. If the random variable is discrete, that means we are having some finite values. If the finite values are, for example, n, then we have to use summation. If the random variable is continuous, we have to use integration. If it is discrete, that is we are having finite values, then we have to use summation. So here the finite values are, I am taking n values, so we have to summate from I is equal to 1 to n. So if we are having infinite values, then we cannot use the probabilities. If we are having finite values, then only we can write the probability for all the n values. So discrete case means we have to use summation and probability. Continuous case means we have to use integration and the probability density function. So this is the format. For continuous case, expectation of any function g of x is integral minus infinity to infinity, that same function g of x into density function fx of x dx. Continuous case means again the integration and density function. Expectation of any function, we have to write the same function here. For discrete case, expectation of a function g of x is sigma, that is summation from I is equal to 1 to n g of xi, the same function here, into probability of xi. So discrete means finite values, therefore summation and probabilities. Continuous means infinite values, therefore integration and density function. So these two formulas, if we remember these two formulas, then these four topics are completed. So here in place of g of x, the function g of x, if I take x, in place of g of x, if I take x, then expectation of x is equal to integral minus infinity to infinity x into fx of x dx. It is nothing but expectation of a random variable, or we can call it as mean value or average value. Similarly, for discrete case also we can write here, in place of g of x, if we take x, expectation of x is equal to summation I is equal to 1 to n xi into p of xi. So if we take anything here in place of g of x, then we have to write the same thing here also. Here we have taken capital X, we have to write here small xi. So this is the first topic. So if we replace g of x with x, then it is called as expectation of a random variable or mean value, or we can also call it as average value. Now if we replace here g of x with x power n, then the formula is integration of x power n fx of x dx. Here for discrete case the formula is expectation of x power n is equal to sigma I is equal to 1 to n xi power n into p of xi. Same x power n, here we are writing xi power n. Then it is called as moments about origin. In place of g of x, if we take x power n, then it is called as moments about origin. So in place of g of x, if we take x minus x bar whole power n, then it is called as moments about mean. Or we can also call it as central moments. So this is moments. We can calculate about origin, that is x minus 0 whole power n or x minus x bar whole power n, that is mean. So again, if I replace here in place of g of x, if I write e power vx, then it is called as moment generating function. Expectation of e power Vx is called as moment generating function. Again here also, if x is continuous, we have to write integration e power Vx fx of x dx. If x is a discrete random variable, we have to write expectation of e power Vx equal to sigma e is equal to 1 to n e power v xi into p of xi. So next, if I replace g of x with e power j omega x, that is expectation of e power j omega x is called as characteristic function. Again the same formula, here in place of g of x, we are writing e power j omega x. So for continuous case, formula is integral e power j omega x into fx of x dx. For discrete case, the formula is sigma e is equal to 1 to n e power j omega xi into p of xi. So for studying these four topics, we only need two formulas. One is for continuous case, another is for discrete case. So it is very easy to remember these two formulas. So again I am repeating, if in place of g of x, if I write x, then it is expectation of x or mean value of x. In place of g of x, if I write x power n, then it is moments about origin. If in place of g of x, if I take x minus x bar whole power n, then it is moments about mean. If we take in place of g of x e power x, then it is moment generating function. If we replace g of x with e power j omega x, then it is characteristic function. Thank you.